Hello everyone. In this module, we are going to discuss working with backend in Matplotlib. And we are going to cover these many topics. Firstly, we discuss the difference between frontend and backend. Then we learn the types of backend. After that, we discuss how to know the backend which we are currently using. Then we learn how to select a backend. After that, we discuss some built-in backends, and in last we see different example related to this. So let's start. You all know that Matplotlib supports a wide range of application and output formats, and some of between us use Matplotlib interactively from the Python shell for plotting a graph, and some of between us use Jupyter notebooks and plots inline graph for rapid data analysis. And maybe other of us use Matplotlib to construct rich apps using a graphical user interfaces like pyqt and pyobject. And maybe some of your other friend use Matplotlib in batch scripts to generate PostScript graph from numerical simulation, and still other run web application server to dynamically deliver graphs. So Matplotlib can target different outputs to support all these use cases, and each of these capabilities is referred to as a backend. So to clearly understand what is backend, we see the difference between front-end and back-end. Firstly, I tell you what is front-end. The front-end is the user-facing code, which we mean plotting code. And by the back-end, we mean it is the code that does all the hard work behind the scenes to create the figure, or we can say that to create a plot. So there are two types of a backend, which are interactive backend and non-interactive backend. We discuss one by one. Firstly, I tell you what is interactive backend. Interactive backend allow us to give interactive plots with interactive features such as zooming, auto update, panning, etc. And it is also referred as a user interface backend. And the another one is non-interactive backend. This backend allows us to give a hard copy of a graphs or a plot. In this, we will take input from user, then we plot a figure in a memory, and then send it through and encode as an image to be shown in the browser or to save to a disk. So I hope you clearly understand what is interactive and non-interactive backends. So now we discuss how to know which backend we are currently using. To know which backend you are using right now in Python and IPython shell, we have the following commands. For Python shell, the command is matplotlib.get underscore backend function. And for IPython shell, the command is percentage matplotlib. And these types of function are known as magic function in Python. So now I show you the execution. So firstly I show you how to know backend in Python shell. For this I open Python shell first by typing a command python. After that I import the library matplotlib by writing a command import matplotlib. After that I write a command matplotlib.get underscore backend, and now I close the function and hit enter. It will show you the currently backend which is used by it. The backend is qtagg. To know the backend in IPython shell, I use the Jupyter notebook. For this, firstly I write the command to import library, which is import matplotlib. After that I write the magic function percentage matplotlib, and now I execute this line. And with this you clearly see that the qtagg, the backend is which we are currently using. Addition to this thing, IPython and the Python provide a list of various backend which are available in Matplotlib. To obtain the list in Python shell, the command is matplotlib.rc setup.all underscore backends, and for IPython shell, the command is percentage matplotlib hyphen l. So now I show you the execution. So firstly I show you in Python shell. For this you have to write matplotlib.rc setup, then dot all underscore backend and hit enter. And here the list of the backends which are available in matplotlib. Now I show you the same in IPython shell. So I write the command percentage matplotlib hyphen l, and now I run this cell. And there is one more command to know the list of backend, that is percentage matplotlib hyphen hyphen list. And now I run this cell also, and you can see that the available backend list are as shown below. You can use any of this command as per your choice. So now we move to the next topic, that is selecting a backend. So the setting of a non-interactive backend in Python and IPython shell is saving plot. To set up this thing, we have to save the plot which we discussed in the previous module, and the command to save it is matplotlib pyplot savefig. So our main focus is the setting of a interactive backend in Python and IPython shell. So there are different ways. The first way is changing the default one. In your matplotlib brc file, set rc params backend, and in backend you have to specify the name of a backend which we want to set. The another is the setting the MPL backend environment variable. This environment variable can set for either your current shell or for a single script. So the command is set MPL backend, then the name of the backend which we want to set for the file, and then we have to write the name of the file in which we want to set it. So the third one is specific backend. If your script requires a certain backend, you can use the matplotlib.use function. And the last way to activate the interactive backend in IPython shell is by using the magic function, that is percentage matplotlib and the name of the backend which we want to activate. Till now we discuss how to set interactive backend in Python as well as in a IPython shell. So now we discuss some non-interactive built-in backends. By default, Matplotlib should automatically choose a default backend that permit for both interactive work and for non-interactive work. So if you want to change, there are some built-in backends which you can use. So firstly, I tell you the non-interactive backends. The first one is AGG backend, and the file type which it save is PNG. The another is PDF, and the file type it save is PDF. The next one is PS, and it saves that file in the format PS and EPS. The another is SVG, and it saves the file in SVG format. The next one is PGF, and it saves the file in PGF or PDF format. And the last one is Cairo, and it saves the file in PNG, PS and PDF as well as in the SVGF format. So these are some non-interactive built-in backends. So now we discuss interactive built-in backend. The first one is Qt-AGG, and it has some requirement which is PyQt or a Qt is installed in your system. The another one is IPyMPL, and it also require IPyMPL installed in your system. The next one is GTK3AG and GTK4AG, and both of these require PyGObject and PyCairo or Cairo SIF installed in your system. So the next one is MacOx. The another one is TKAGG. So it is used to rendering the TK canvas, and for this you have to install TK Inter in your system. The another one is NBAGG. So it is used to embed interactive figures in Jupyter Notebook. The another one is WebAGG. The another two are GTK3 Cairo and GTK4 Cairo. It also has some specific requirements which is PyObject, PyCairo and CairoSIF installed in your system. And the last one is WXAGG, and it renders the plots in WX Winget's canvas, and it has also a requirement of a WX Python 4. You can use any of these backend as per your choice. Now I show you the example in both Python as well as in a IPython shell. So firstly I show you the example in Python shell. So firstly I import the necessary libraries. First, that is import matplotlib pyplot as plt. Then I import the numpy library. Import numpy as np. Then I import the matplotlib library. After this, I specify the backend which I want to use by using a command matplotlib.use and the name of the backend. I type the name as a tkagg. For this I mean I want to use the backend tkagg. So next I define the data coordinate. Firstly I define the x. For this I use the numpy array function which is used to create array in numpy. Then I define the y coordinate which is x multiplied by 6. Then I plot this graph by using the plot function, and to display the graph on the screen I use the show function, and you can see that it plots the graph in tkagg backend, and it has some features like reset original view, back to the previous view, the forward to the next view, left button pans, right button pans. The another one is zoom to rectangle. The next one is configure subplots. You can click and here you can see that it shows you the slider to adjust the subplot. If I extend the left one, you can see it shifts the y-axis. If I move the bottom one, if I change the right one, if I change the top one, with this you can change anything. And this is the save option to save this plot in your system. So I reset this to the previous setting. So now I show you the interactive backend using IPython. So firstly I show you the notebook backend which is also known as NBAGG backend. So I use the same example as I use in Python shell. The difference is that I set the backend here by using the magic function which is percentage matplotlib notebook. So here I use the notebook because I want to set backend as a notebook. So I run this code and you can see the example. I show you one thing. If I plot something else and execute it, you can see that the line appears on the same plot. So you can stop this by click on the button, and it also has some features which is home feature, back feature, the forward feature and the pan feature. The another one is zoom also, and the next one is download. So you can see that it zoom the graph. If I use the pan function, moves the graph. So with this we know that how the interactive plots looks. So I stop this. I show you one more example. Here I set the backend to the qtagg. So here I use the magic function as percentage matplotlib qt. So I execute this code and here you see that the plots appear in qtagg backend. It also has some features. The first one is reset to the original view. The next is back to the previous view. The another is forward. The another one is left zoom pans. And next one is zoom to the rectangle. The next one is configure subplots. And it's look something like this. You can set the top, bottom, left, right, H space, W space settings and the borders. The another is edit axis. So by using this, you can set the axis limits, x-axis limit, y-axis limit, as well as the labels for both the axes and also the scales, and even you can set the curves, which type of the line you want to plot, draw style of a marker or a size of the marker, even the face color you can set by using this option. And the last one is the save option. So let's see one more example. Here I set the backend as IPyMPEL. Now I execute this code and here's the output appears. The first option is the reset original view option, and the another two one is the back to the previous and the forward to the next one. The next one is the left zoom pans or a right zoom buttons, and the next one is the zoom to the rectangle, and the last one is the download the plot. If I use any of this, you can see it zoom in the rectangle, zoom in the plot. So here it is zooming, and here you can stretch this plot. So with this we learn how we can change the backend of a plots, and in the next module we will learn to change the color of the lines which we plot in the graph.